All right, this is chapter 6.3, graphing radical functions. All right, let me scroll down a little bit. Here are your core concepts. These are your two forms that come out of it. Either A, you'll get one that's just got the little swish, like this one right here. And the reason that happens is because this you have an even root. And what I mean by that is like a square root, a fourth root, a sixth root, things along those lines. And the reason you only have this side is because can you take the square root of a negative? Yes, you get an imaginary number, but can you get a real answer? The answer is no. So we're not going to get anything on that graph. Okay, you only have the right side. Likewise, over here, this is the completed. It's got that right side just like the evens do, but it's also got this because you can take an odd radical. So this would be your third root, your fifth root, your seventh root, so on and so forth, till death do us part, all that sort of stuff. All right. So those are how they're going to look different. There's a few other few differences. Your domain and range. For an odd, it's all real numbers because it goes left forever, it goes right forever, it goes up forever, it goes down forever. Your domain and range for an even starts wherever this endpoint is, which remember an endpoint is where the line ends. Those of you who remember geometry. No, geometry in my algebra. But it's where the line ends, so that is your endpoint. But we start at the endpoint, and you go in whatever direction it is. So in this one, it's 0 to infinity and 0 to infinity. If the endpoint was over here, it might go that way. But wherever that endpoint is, and whichever way the line is going, that is what you're going to use for your domain and range. Okay? Finally, your odd numbers do not have endpoints. So like this one right here, we call that an endpoint. O-I-N-T. And I know that looks like an H. For some reason, my pen does not want to work. Let's clean that up. E-N-D. That's an end point. All right. This is actually called an inflection point. All right. And the reason for that is a little complicated. You don't have to memorize this, but it comes true in calculus. If I drew tangents on this, so that tangent right there, the slope of that line is positive. The slope, as I move along, I move tangent after tangent, it gets steeper and steeper until I get to that point right there, I am truly vertical. Okay? And then it starts to taper off again. My tangents get lower and lower. The reason it's called let me erase all those. The reason it's called an inflection point is because my tangent line is up and down. It's that perfect up and down line right there. Thicken it out a little bit. And inflection points and endpoints, as well as vertices. You know, when a graph goes like this, that vertice, that tangent line is right like that. Those are very important in calculus, and many of your professions will use things like that as important parts of functions. All right. And so we call them, they're called an inflection point because that's where the slope either becomes 0 or infinite. All right? Not that you got to memorize that, but if that helps you learn why, that's what it is. All right, let's scroll over to the next page. Pause if you're still copying, but I'm going to scroll over to the next page real fast. All right, number 1. First things first, we're going to talk about, does this have an endpoint or an inflection point? Well, is it an even root or an odd root? It is an even root. It has a 1, it's to the 1/2, so it is a square root. Because it's an even root, it has an endpoint. Okay? The location of that endpoint is at 5, -4. Okay? And that's simply because of this and that. Remember your transformations? Inside is x and backwards, outside is y and normal. Well, inside we're subtracting 5, so it's really a positive 5. Outside we're subtracting 4, so it's really a -4. So that's where your endpoint is. We're going to find the inflection point the exact same way, whatever's adding or subtracting to the inside and outside. Okay, so there's that. So I'm going to put in my x and y, -5. I'm sorry, -5. Positive 5, -4. Okay. From there, I'm going to go to my calculator. So let me pause real quick. All right. And so I went to my calculator. I plugged it in. And to me, in my calculator, it's always easier for me to put 1/2 than it is to me to find the square root button, or find the cube root button, or find the x root button, and do it that way. If it's a third root, do it to 1/3. An eighth root, do it to 1/8. That sort of thing. It is easier for me to write it as a fractional exponent in the calculator. But we'll put it in the calculator, and then go to your table to find points. All right? And the first thing you'll notice that everything above your endpoint says error. All right? The reason it's that way is because you cannot do it and get a real number. So like for x is 4. For the x above the x is 4. If I did put 4 right there, 4 minus 5 is -1. Can you take the square root of a negative? No. So the calculator spits out an error. All right? Now, just because everything above is an error does not necessarily mean that that is your endpoint, although it's a pretty good indicator. Okay? Simply because it might be decimals. If it's decimals, it's not going to show up. It's just going to tell you the whole numbers. So from here, what I do is I'm just going to write down the whole numbers. So I got 5 -4, 6 -2. I keep on scrolling down. I got 9 0, and I got 14 2. I don't feel like dealing with it. And so I'll graph it. My x's go from 5 to 14, so I don't need any negative x's. So I'm going to put my x-axis way over here. And then I go from -4 to 2. Yeah, so I'll put that right there. And I think my x's I'm going to count by 2's, and my y's I'm going to count by 1. If it drives you crazy to count by different units, that's fine. You can do what you want. You can count them both by 2's. But the reason I'm counting that by 2's is because I got to go from 5 to 14. And there's not that many lines, I don't think. Well, so here we go. 5 -4. So 2, 4, 5 would be right there. 5 would be right there on the line. -1, 2, 3, 4. Okay. 6 -2. 6 is right there. -2. Let's go down 2. We've got 9 0. So 6, 8, 10 would be right there. So 9 is right there. So that's 10, 12, 14, 2. 1, 2. All right. So those are my dots. This is my endpoint. So I'm going to go. And that's your graph. Okay? Easy peasy, chicken greasy. To get the domain and range, notice I need my x values and my y values. Remember, x is domain and y is range. So let me do it in a different color. My x starts here at 5 and goes right forever, correct? So it is from 5 to infinity. My y value starts here. My y value starts here at -4 and goes up forever. So the lowest point is -4. The highest point is infinity. Cool? And that's how you do it. Try number 2. Try number 2. Pause the video. Try number 2. But otherwise, I'm going to burn right through it. All right, so here we go. This one is also an even root, so it's also going to have an endpoint. And that endpoint is at -3. -3, 0. Okay? Because -3 is what's being added or subtracted on the inside. There's nothing on the outside, so it's a 0. Because we don't write +0. So your endpoint is at -3, 0. And I'm going to go to my chart, and I find, oh, here we go. -3, 0, -2, -1, 1, -2, and let's get one more. 6, -3. Okay. My x's go from -3 to 6's, so I'm going to put this right here. I can put it in the middle somewhere. I'll move it left because I need more positives. And my y's go from 0 to -3, so I'm going to put I need negative, so I'm going to put that up there. Okay. And then just graph it out. So -3, 0, 1, 2, 3, 0. -2, -1, -2, -1. 1, -2. That's right there. And 6, -3. 1, 2, 3, 4, 5, 6. Ooh. I'm glad I put it where I did. I almost ran out of space. Okay. And so there's your graph. Starts there and goes. Right. Now it's important you realize that that's an endpoint, because you might be tempted to kind of go like this. That's not what's happening. It's ending right there. Okay? That's why you got to know it's an endpoint. Your domain and range. Okay. Your domain, your x values. Okay, so it starts here. Move to the right. So it is from -3 to infinity. This one, the range starts here and goes down. Now remember, put it in numerical order. So we're going to start with the -infinity, and we're going to go up, get rid of that tiddly, up to 0. Okay. If you put 0 to -infinity, I understand what you did. That is not fine. You have to put it in numerical order, okay, or counting order. But otherwise, good job. All right. See how you did. See what's going on, and go from there. All right. I'm gonna pause. I'm gonna stop, and then I'm gonna come back and do 2 and 3 and 4.